Hello and welcome to our Christmas Space Talk. My name's Helen Ward. I'm the director of the STEM Hub, and we are very excited to have Libby Jackson, the author of the book Space Explorers, talking to you today. Libby is also the flight director at the Columbus Control Center and was involved in Tim Peake's expedition into space.
Ignition sequence start. All engines are running.
We have taken tremendous steps.
We choose to go to the moon before this decade is out.
We have achieved the earth-shaking, the breathtaking, the groundbreaking.
One small step for man.
And left a mark in the heavens. Our successes build one upon another and amplify what is possible.
The dawn of Orion.
It's time we take the next great leap.
Hello everyone. I think you can hear me. I'm hoping you might be able to see me in a minute, just so I can say hello to everybody before I bring my slides up. That I can see the technical wizardry happening in the background, and everyone's working. And there you go. Yes, I think you can see me. Hi everybody. Hello. Oh, it's so good to be talking to you today. I wish I could be there in person in your classrooms. We're all, of course, having to be stuck at home to make sure we all stay safe and to keep this coronavirus at bay so we don't all get sick, everyone. But it's wonderful to be talking to you. And I hope now, by the magic of technology, if I click a few things here, you can hopefully see my slides. I'm going to trust that you can and hope that somebody in the background is going to shout if you can't. So, Christmas in space. Why am I here? Why am I talking to you? Well, let's work this out. There you go. This is me. You can see me on the left, and some of you might recognize the person I'm standing next to. And if you don't worry. The person I'm standing next to is called Tim Peake, and you might know the name Tim Peake. He is a British astronaut. He's not the first one. The first one was Helen Sharman, but he is the current active British astronaut. And 5 years ago, when I suspect some of you were quite little, he went into space and he lived and worked in a place called the International Space Station. And I've worked with Tim for many years. I've worked in the space industry and in human spaceflight for many years, which is really exciting for me because ever since I was little, I loved space. I've always been fascinated by space, what's out there, the stars at night, and particularly astronauts, the adventures they get up to, and all the people who work on Earth to keep them safe and sound. And when I was little and going to school, I never thought that I could have a job working in something I was interested in, but I liked science and I liked maths, and I kept working at things I enjoyed. And after I went through school and I took all my exams and I went to university, I ended up working in mission control. And this is me sitting in mission control in Europe, in Germany, where I was a flight director, a Columbus flight director, working in mission control around the clock, looking after the astronauts on the International Space Station. And this is the International Space Station. You can see the International Space Station with your very own eyes. If you know when to look in the sky at night, it flies overhead and it's so bright, it looks like a really bright moving star, and you can wave at the astronauts in it. So this was what I used to do. I still work in the space industry now. And the little part of the space station that I looked after was the Columbus module, which is this bit. It's Europe's science laboratory in space, where we do some amazing science experiments. And there are so many great stories I've learned about through growing up, through working, reading about the astronauts, the moon landings, which I wasn't alive for, and working in the industry now. And I've put all of the very best stories into this book that Helen was showing you earlier, called Space Explorers. And it's out now, and it's fabulous. I think it's beautifully illustrated. And I'm going to give you a little bit of a flavour of some of the things that you might find in that book. But really what I want to talk to you today is, because it's only, what are we now? Oh, nearly just 2 weeks till Christmas, something like that. I think it's 2 weeks today. I'm going to talk to you about what happens with Christmas in space. But before I do, I thought I'd tell you just a little bit about the International Space Station in case you don't know about it yet. So this is the International Space Station, looking very Christmassy here. It's flying over a bit of the world that's covered in snow and clouds, and that's why it's white behind it. And as I said, the International Space Station is an amazing, huge scientific laboratory up in space, where the astronauts are, where they float. And it's currently inhabited by 7 people. These are the 7 people who are living and working in space right now. And for your entire lives, the whole time you've been alive, there have been people on that space station. So every single human being who's been alive for the last 20 years has not been living on Earth. There's always been somebody in space for the last 20 years, which I think is amazing. So they up there, so they're doing fantastic science. But to get there, they've got to take a rocket ride. And this is the crew who launched just a little while ago in a brand new spacecraft called the Dragon spaceship. And this was them waving goodbye to everybody before they got into their rocket. And I'm hoping, fingers crossed, let's see what the technology does, if I can make this work. I'm never sure. This doesn't always work. Let's see. Oh, what's it going to do? I tried this out and you think it's going to work. I'm really hoping I can show you a rocket launch. Let's see. Here we go. I think we're going to see it. Yes. It's coming.
T-minus 15 seconds. Falcon 9 is configured for flight. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Ignition. Liftoff.
And resilience rises. Not even gravity contains humanity when we explore as one for all.
M1 propulsion is nominal.
That's the word we want to hear. Stage 1 propulsion is nominal.
Dragon. Minutes to get from Earth all the way up to the International Space Station, where you are traveling at 17,500 miles an hour. And once you get there, all the astronauts are living and working there. And just like you at school today, who are sitting down listening to me now, maybe this morning you had a maths lesson or a reading lesson, or you were out running around outside doing some physical activity. Or you're doing art or drama, who knows what you're doing, but you probably had a schedule. And the astronauts, just like you, have a schedule every single day. So they work from Monday to Friday, from about 8 a.m. to 6 p.m. They don't have to work the weekends or the evenings, but they do every Saturday morning have to clean the space station, just like all of us do at home. So this is the schedule that they all follow, and they keep going. And what they're doing during those days mostly is science experiments. So we send astronauts into space and we keep the International Space Station there because we can do science that you cannot do on Earth. When you're in space, you're floating. And astronauts and everything in the space station float because they're traveling so fast at 17,500 miles an hour that they're falling around the Earth. It's a little bit like if they went up in a plane and they jumped out the plane. You can imagine someone before when they do a parachute jump, you see them free flying down and down to Earth, and before they open their parachute, they're just falling towards Earth. And now if you're falling towards Earth like that and you had a ball out in front of you, with a little ball inside, so imagine you had a big transparent beach ball, and then you put a tennis ball inside it and you held it out in front of you while you were falling down to Earth, you would see that the tennis ball was floating inside the middle of the beach ball. And that's exactly what's happening to the astronauts in the space station. They're fortunately not going to crash into Earth because they're going sideways so quickly that they fall round the Earth, and that's why everything floats. It's not because there's no gravity in space. There is gravity everywhere. Everywhere in space there is gravity, but it's that you can't feel it. And when you can't feel it, we can find out how things work, because here on Earth, gravity is everywhere. It's always pulling us down. It's always getting in the way. And when you can't feel it, you can look and see how things behave, and you can learn new things. And one of the things we spend a lot of time doing is learning how astronauts change. And here you can see Tim Peake and Tim Copra taking some blood from Tim Peake. And we do that because when you go into space, you essentially get really old really quickly. Your bones and your muscles deteriorate, your eyesight changes, your skin gets thinner. All of the things that happen to all of us as we get old. If you know older people at home, maybe you've got some grandparents or some friends or something like that, people you go and see, and you think, well, they're less able to move and their skin is different. That's what happens to the astronauts. And it's really helpful for us to understand how humans change and get old by studying what happens to the astronauts in space. So that's a lot of what the astronauts do, but it's not everything that they do up there. They are also doing lots of experiments. This is Kate, who is up there now. She's looking at how plants can grow in space. These are radishes that are growing. We're trying to learn how to make new foods grow in space, because one day we might want to send humans to Mars. And as you'll see in a bit, you really don't want to eat tinned food all the way. It's really nice for us to learn how to grow plants in space, and that's what we're doing here. And here's Victor, who's up there already as well at the minute. He's installing a new experiment. And a lot of the experiments on the space station aren't done by the astronauts, but they're done by people back on Earth. You've got a sign here that says, don't touch, do not running. And that experiment is being controlled by people like this, sitting in little control rooms all around the world. So as well as the astronauts in space, there are loads and loads and loads of people all around the world doing lots of different jobs to make the astronauts safe and to keep all the science running. Now, as well as doing all the science, the astronauts have to stay fit and healthy. All that floating around in space, all those bones and muscles getting weaker, we need the astronauts to be able to be healthy when they get back to Earth. And this is Tim, my friend from the beginning. He ran a marathon in space, and you can see him here strapped to the treadmill, little bungee system around him, and that's how you run in space, and it helps keep you fit. You do that for an hour every day if you're an astronaut, and you also have to do strength exercises every day. On Earth, we might lift weights to make our muscles strong. Because nothing has any weight in space, because it's all floating, we have to use things like big elastic bands, essentially, to pull things, resistance exercise to make the muscles stay strong. You've got to do lots of exercise. And just occasionally, you get to go out and do a spacewalk. They don't happen that often, but because they're quite dangerous. But sometimes we have two people go outside, and here are Christina Koch and Andrew Morgan replacing some batteries on the outside of the space station. It's not all hard work, though. The astronauts get the weekends off. They get their evenings off. They can ring friends and family. They can have video chats, and sometimes they'll sit down and watch a movie. And here you can see what a movie night in space looks like. And they're watching Star Wars, which I think is brilliant. But one of the favorite best things that all astronauts like to do is to look out the window back at the beautiful views of Earth. And this is Jessica Meir in the cupola window, which is this wonderful window the astronauts have got to see the Earth. And I'm really hoping that this video is going to work, because it's just quite beautiful. I think we might have to be a little bit patient, but fingers crossed it is coming. Let's see what happens. Here it's coming. Watch this. Can you imagine living and working there? It's amazing. It's so beautiful. No wonder they like spending so much time looking at the cupola. That video is available on YouTube, and it goes on for 20 minutes, and it's a fly through all the way through the space station, and it's brilliant. If you get a chance, well worth checking it out. So that's what life is like on the International Space Station. But what I really want to tell you about today is Christmas, because we're all getting excited, I hope, about Christmas. And they celebrate Christmas on the International Space Station. And you know what? It's not once, but twice. Twice they get to celebrate Christmas, and that's because it's an international crew. So as well as celebrating Christmas on the 25th of December, like a lot of us do here in the UK and across Europe and in the United States of America, and there's always crew from the United States of America on board, there are also always crew on board from Russia. And Russia celebrate Christmas in early January, usually on the 7th of January. So everybody gets to celebrate Christmas twice. So I think that's really exciting, one of the best bits about being in space. So right now, the astronauts are all getting ready to celebrate Christmas. And you know what? I think one or two of you out there might currently be getting ready to celebrate Christmas and have some visitors in the form of some elves. And the elves get to the space station too. So here's one of the elves that was spotted last year or the year before. And they're looking on longingly at the freezer. This is the Melfi freezer, -80 lab freezer. And it's where lots of those samples that we saw Tim drawing, those blood samples, get stored before they get returned to Earth for all the scientists. And it's really cold inside. And maybe that's why the elf is looking on longingly, because it's reminding them of Lapland. So once we get closer to Christmas, just like many of us here, the crew hang up stockings, and you can see, if you look closely, all their names are written on it next to the tree. This was Samantha, and there was Terry, and there was Anatoly, and lots of Russian names. And they hang them up and they wait to see if any presents come. And then if they've all been good on Christmas Day, they get to open their presents. And just like many of us do, the crew get dressed up. Here's Peggy with a hat and some great socks on in the cupola, and they all have a bit of a party and they get to have a big meal together. But unlike us, perhaps with Christmas crackers, and maybe some turkey and some vegetables and some gravy, if you look closely in the middle of that picture, the food looks a bit different, because all the food really in space, nearly all of it, has to be made so it's long life. You only get deliveries of food every 1 or 2 months, so a lot of the food is in tins or it's in foil pouches, so it's long life, or it's dehydrated. And everyone on Earth who looks after the food really tries to make sure that the food is as nice as possible, but it still doesn't always look that appetizing. And here was Mike with his celebration meal. This was on Thanksgiving, actually, which is very similar to what they eat to Christmas. It's the big American holiday that's just happened. And you can see he's got some turkey, and he's got some mashed potatoes, and he's got some vegetables, and he's got a little bit of stuffing. But it's all in plastic pouches. It doesn't look very appetizing, but really this is as good as it is. And if you look in the right of the corner, you can see his water in that big foil pouch there. And this is how they eat food. And I'll tell you the thing about this food. Because everything that goes to space has to come up on a rocket, we really try hard to make sure that everything weighs as little as possible. It has as less mass as possible. And that means that most of the food that goes up to the space station is dehydrated. So it means it's been dried out, all the water's been taken out of it. And then in space, the water gets added back in, and it reforms, it absorbs all the water, and it turns back into food. So if you've ever had some instant mashed potato or some pot noodles or something like that, anything where you just add water and wait, well, you've eaten like an astronaut. That's how they eat. The other thing you might be wondering is, well, where does all the water come from? And it gets recycled on the space station. It goes round and round. All the water that goes into the toilet and is collected in the air conditioning systems and things, that gets collected and cleaned, and then the next few days it comes back out the tap again and used again. Just like here on Earth, it's just that it's all a bit closer to home on the space station. So whilst this is all happening in Christmas, everybody in mission control is watching over everybody, and indeed that's what I used to do. And I had one Christmas I particularly remember when I was working, when the space station really went wrong. It was a big problem with a big failure. I got really worried at one point. I had to have lots of meetings, and it was a pump on the outside that was cooling the space station, and it stopped working. And they've got a few pumps, so it wasn't the end of the world, but it was quite critical. And in the end, there was a spacewalk on Christmas Eve that fixed it all. And it was on Christmas Day, finally, that I could breathe a sigh of relief because I'd got everything back to normal. So this Christmas is always happening in space. But very quickly, I thought I'd tell you a little bit about the very first Christmas in space, which were these three people. And you have to go right back to 1968. And this is Jim Lovell and Bill Anders and Frank Borman. And they were the very first astronauts to spend Christmas in space. And not only were they in space, but they went to the moon. They were the very first humans to leave Earth and to go and visit the moon. And they flew on this giant rocket called the Saturn V. And they were the very first humans ever to get involved and ride on the top of this rocket. And the last time this rocket had flown, it nearly exploded. It was a really daring and dangerous mission that America decided to do because they were racing to put humans on the moon with the Soviet Union, the big country that now is mostly Russia. So Frank and Bill and Jim got on this rocket and they left Earth's orbit, and they went further and further and further away from Earth until the Earth was hanging in space just like we see the moon. But all the journey there, they couldn't see the moon until they got there. Suddenly, there was the moon. And they were amazed how beautiful and different it was. And they spent so much time taking photographs of the moon as they orbited around the moon that they didn't really look out the sides. And then a few orbits later, they were looking out the side. And then they got to see this. They saw the Earth rising over the moon like we see the sunrise or the moonrise here, and they took this picture of Earth. It's a very famous picture of Earth called Earthrise, and it's the first time that humans have seen how precious our planet is from such a long way away, and what a little blue marble it is hanging in space. And it's so precious. When you think about the Earth, you think of the Earth as a football. And I don't know if you can see me, I've got one here. It's a little tennis ball, but you think of it the size of a football. The atmosphere, all that blue and the clouds and the white that you can see there, everything that keeps us alive is the size of a human hair on that football. It's tiny and it's so precious. And it's really important today, of course, that we look after our planet and that we keep it for all of everybody around the world to keep living as you know, and that we look after it. And that's one of the great things that space helps us with, because we can look at the Earth from far away. So this was the first time we'd seen that photo. This time was the first time that we'd seen the Earth from that great distance. Before we had to see that picture, though, the astronauts had to come home and they had to fire their engine behind the back of the moon, out of sight of Earth. And everybody on Earth worried if they would be able to get home. And when the astronauts appeared from behind the moon and could talk to Earth again, this was what they said.
Houston, Apollo 8, over.
Hello, Apollo 8. Loud and clear.
Roger. Please be informed there is a Santa Claus.
That's affirmative. You're the best one to know.
And first status report.
There you go. That was how the astronauts knew they were coming home. They knew there was a Santa Claus because they had spent Christmas at the moon. They got safely home. They landed. They were greeted as heroes for going to the moon for Christmas, and they brought that beautiful picture back. And now that story, and some others that you might know about, but maybe not everything, are in the book. Neil Armstrong and Buzz Aldrin landed on the moon just 7 months after that crew had gone, the crew of Apollo 8 had gone all the way to the moon. But they also nearly didn't make it back. And if it hadn't have been for a felt tip pen, they would still be stuck on the moon today. Can you believe it? That's true. All the stories in the book are true. Even the one about how the International Space Station was saved by a toothbrush. And now they're all true, except for the very final story. And Helen mentioned it a bit earlier. The very, very last story in the book, I've done a little bit of imagining and dreaming about what it will be like when humans set off to go and explore Mars. And I think in your lifetimes, you will see humans exploring Mars. And that's the challenge I want to set all of you. So what's it going to look like? This is a picture from back in the 1990s from NASA. They were thinking, what might it look like when humans are on Mars? And I want you to imagine that. What's it going to be like? What's the inside of these habitation modules looking like? What are you going to need to explore Mars? How are you going to live there? It takes a year to get to Mars with the current technology. You've then got to stay on the surface of Mars for another year. So 9 months to get there. You've got to stay there for a year and 9 months to get home. 2.5 years away from Earth and a year living on another planet. You've got to take everything there. You've got to take everything that you need to explore. You've got to grow your own food like Kate was doing. You've got to be able to go and do the science. You've got to explore Mars, see if there's evidence of life there, see what we can learn about the planet. Lots to do and lots to think about. That's my challenge to you. And now, before I finish, I think there might be one more question about Christmas in space that you might be wondering about. You remember I showed you this photograph of the astronauts with their presents? Or how did they get them? How did Father Christmas, how did Santa Claus get to the space station? Well, I tell you, he gets there every year. And we know this because we're quite good at space. There's so many things in space and so many satellites up there that we all use every single day for looking at our weather forecasts, for figuring out where to go with our sat nav, when we pay for things, when we look at television programs that are being beamed live from the other side of the world, like the Olympic Games or a football match, something like that. All of that is using space. And so there are clever people who are always tracking what's going on where and where all the satellites are in space so they all keep safe. And every year, they see a mystery object appear that whizzes around the world really, really quickly, visiting all the countries and the space station. And they track it. And you can follow it too at this web address, noradsanta.org. So you really can follow Father Christmas. And I promise you, he gets into the space station. And that's how the Christmas presents get there. So that's everything I want to share with you. A reminder, the book is available. If you want to learn about those stories, go and have a look. I'm really, really pleased with it. I think you would enjoy it too. And that's all I wanted to tell you about Christmas in space. And I hope there are some questions out there, and I'd love to be able to answer them for you. And thanks so much, and looking forward to your questions.
Thank you, Libby. That was amazing. There are lots of questions, and there's quite a number of them that really want to know whether, when you decided that you knew that you wanted to get involved in space.
So when did I know that I wanted to get involved in space? It took me a really long time to figure it out, actually. So I always liked space. It was always something I was fascinated by. If you can see behind me, I've got lots and lots of books on my bookshelf. I would read all these books as I got older, when I was a teenager. But it really didn't occur to me for a long time that I could get a job in the space industry. I didn't know when I was young that here in the UK, we have a space industry. We're really, really good in this country at building satellites that go into space, and we have to fly those satellites. So as I got older, I sort of realized this, and I started to think, well, maybe I could. And it wasn't until I was at university, and I studied physics at university, and realized that I didn't want to be a physicist, I started to think, well, maybe I could be an engineer and go and work in the space industry. And so I did a degree in space engineering, and then I started looking for jobs that were to do with mission control, because that was the thing I really liked. And I just looked, and I just thought, well, somebody must have to do it, so why not me? And I didn't listen to anyone who laughed at me or told me that I was being silly. I just got on with the things I like doing. And so I got a job working in mission control here in the UK, looking after some satellites. And then from that, I thought, well, if there's going to be mission controllers over in Europe for the International Space Station, that's something I'd really like to do. And so I looked for jobs, and I got that job. And here I am now, having spent nearly all my life working in human spaceflight in this thing that I enjoy. And I think for me, if you get nothing else out of today, that is my most important message to all of you. Whether it's space or whether it's anything else, whatever it is you like doing, you can get a job in it. I promise you. There are jobs in all sorts of different things. And if you want to do it and you work hard, you can do it. The only thing stopping you is you. You don't listen to the people who say you can't. You've got to work hard. You've got to dream. And your dreams might change, and that's okay. But if you do things you enjoy, you'll do them well. And you can come and work in the space industry just like me, or anywhere else that you would think is exciting.
Thank you. Moss Head Primary School want to know, are there many women involved in space flights?
Oh, Moss Head Primary School. Yes, there's lots of us. Lots and lots. I've written another book about that, actually. It's called A Galaxy of Her Own. There aren't as many as there should be, but that doesn't mean there's not room for more. And anybody who wants to work in the space industry is very welcome to and should feel welcome to. I've been lucky as I've been growing up. Back in the 60s, when I was the time when we were talking about the Apollo astronauts and that Apollo 8 mission just then, people would look at girls and women who wanted to work in engineering or maths and sort of saying, no, you can't do that. You know, they would really think that you shouldn't do that and couldn't do that. And that's not true. And women have fought and shown that we can and we should, and we're completely capable of doing it. And today there's still not so many women in there. But that's not because they're not welcome. It's just because sometimes people still think they can't. And that's nonsense. If you want to do it, you can come and work there. And we'd love to have you. I really don't ever get treated differently because I'm a woman. And I don't mind when I'm in a meeting and there's lots of men around, lots of boys around. But I'd love to see more women there. I'd love to see more of everybody there. So, yeah, really, don't ever be put off by anyone who says that space isn't for girls, or the other way around. There's lots of other jobs out there which are done often by girls, and the boys think, oh, I'm not sure I should do that. If you want to be a ballet dancer and you're a boy, some people laugh at you, and that's silly. If you want to be a ballet dancer, of course you can do it, or a teacher or a nurse. Everybody should be able to do what they want to do, and it doesn't matter what you look like or where you've come from, what you believe in, you can go and do it.
Thank you. St Bede School have asked lots and lots of questions. The one I've chosen is, do you think we will ever reach Neptune?
Oh, do anyone ever reach Neptune? That's a great question. Well, I think humans going all the way to Neptune is not going to happen for a very, very, very long time. Even to get to Mars, which is our closest neighbour in the solar system, and I say it's going to take 9 months to a year to get there, is very difficult. And we still don't have all the technology and all the answers about how we might do it. And Neptune is a long, long, long way away. But we have visited Neptune. We've sent spacecraft there to visit it and to take pictures of it. And you can look on the internet, you can find the pictures. But to get out there takes 10, 15 years, something like that, years and years and years. It would be a long, long time. It'd be a lifetime of a round trip for humans. But by sending spacecraft out there, we get to learn and see pictures. And I think we will see more spacecraft go out to Neptune in your lifetime. So we'll get there, but maybe with robots rather than humans.
We've got a whole range of different age groups listening today, and Year 2 from St Mark's in Kent want to know, when rockets blast off, is it fire that's coming out of the engines?
Oh, great question. Well, St Mark's, in the launch I showed you, it is. It's exploding fuel that's being thrown out the back of the rocket, and you do that. You can imagine how it works. If you stand on something like a skateboard, and you hold a football or a big ball and you throw it off there, you'll go in the other way, and that's how rockets work. The fuel that they carry up, they explode it. Forces it out the back with a big thrust, and that pushes the rocket in the opposite direction and sends it into space. And in the picture we saw, it's exploding fuel. It's a fire that's breathing out the back of it. But it doesn't have to be. There are other rocket engines that use just inert gas that's not exploding. and it's accelerated through a magnetic field. So you have charged particles. If you have like a magnet, and you imagine that you can go and press that magnet on things that are magnetic, you can have particles, little balls of gas that are attracted to a magnet, and you accelerate them through a magnetic field, and they get spat out the back because they've rushed towards the magnetic field and gone out the back, and they'll push you very gently in the other direction. So rocket engines are usually fire, but they don't have to be. But it's absolutely, in that one, that was exploding fire. It's very dangerous sitting on top of a rocket as a human. You want to make sure it's going to work, and there's always an emergency escape system. So if the rocket did start exploding and the fire got out of control, you could whisk the astronauts to safety and get them back to Earth in one piece.
Thank you, Libby. It's really interesting, some of the questions. And one of the ones that really interested me is, how long does it take to build a space rocket? And that's from class 3, 4, 5 and 6 at Clifton Primary School in Cumbria.
Oh, wow, in Cumbria, it's a brilliant question. Hello up there. I'm down here in Swindon, that's why I think you're up there. The real question, the real answer is it depends, actually. Building a space rocket sometimes can be quite quick, but you have to design it first. So some rockets have been flown for years and years and years. The Soyuz rocket that the Russians use, and they used back in the 60s, that design hasn't really changed for years. So they haven't got to design it. They just build it and they assemble all the different bits. And that probably takes, about 6 months to a year to produce all the parts and put it together. But if you're designing a new rocket from scratch, as America are and have been doing with the Falcon 9 rocket that took the astronauts that we saw there, or their big news called SLS rocket that's going to take astronauts to the moon. Well, that SLS rocket has been more than 10 years in the development. So it takes a long time sometimes to make sure all the different bits work. I said you don't want the thing to go wrong because you'd explode. And so you sometimes have to do a lot of testing, and you do a lot of explosions without the humans involved to make sure that everything is right, and that can take years. But one of the exciting things about the Dragon capsule that I showed you that launch of at the beginning, and the Falcon 9 rocket that's taking it up into space, is that it's reusable. And so the rocket that we saw launch landed back on Earth, part of it, and then it's overhauled, it's refueled, and off it goes again. So you don't even have to build that bit again. You just sort of check it out and you can use it again a few months later. So it really depends, from just a few months to 10 years.
Sorry, I was on mute. Chorleywood Primary School, Year 5, want to know, what is the favourite part of your job?
Oh, what's the favourite part of my job? Is a lovely question. Well, my job today involves looking after everything that the UK does in human spaceflight. So I get to talk to lots of scientists, people up and down the country who are building experiments to go into space. I get to talk to lots of people in industry, the people who are building and designing satellites and spacecraft. And I get to talk to lots of people like you. I get to do a lot of talking about space as well. And really, for me, the favourite bit of my job is that every day I get paid to learn and to talk about something I've always been interested in. So when I'm looking to see what's going on with the latest rocket launch, or when are we going to take people to the moon, that's my job, and I think it's great. And so really the favourite thing for me is that I'm doing something I really enjoy and that I'm interested in. And then the second favourite bit is that I get to talk to lots of lovely people like all of you out there. I love sharing the stories of space and talking about space and sharing the excitement, because I think space is fabulous. I think a lot of people get excited and inspired by what's out there, and it's great to be able to explain why we do it and what the benefits are and why it's so exciting.
Thank you. Very interesting question from Norton St Nicholas School. Does time go at a different speed in space?
Oh, that's a great question. Hello. Yes, it does. It really, really does. There was a scientist called Albert Einstein. You might have heard of him. He was a physicist, very clever physicist who figured out all sorts of things about how space and time work. And he's got a very famous equation, which is E equals mc squared. Energy equals mass times the speed of light squared. That's what it means. What it means is that the faster you get, the slower time goes. And so the astronauts in space, because they're going around so quickly, because they're traveling at 17,500 miles an hour, relative to us, we're sitting here stationary on Earth, they do see time go a little bit slower. But funnily enough, I saw Tim Peake just yesterday, and he was telling me that he had been told that for his 6 months in space, he was about 0.07 seconds, so less than a hundredth of a second, no, less than a tenth of a second younger than he was had he have not been into space. So time did go teeny tiny little bit slower for him, but not really enough that it's going to sort of, you know, make his life feel much longer.
Thank you. I wonder, we haven't got much time left for questions, but I wondered if you could answer Class 4 St Oswald's Primary School in Kendal want to know what would happen if the moon stopped spinning.
What would happen if the moon stopped spinning? Goodness me, that's a good question. Let me see if I can think about this while I'm talking to you. Well, that's a really good question. So the moon is spinning on its axis, like the Earth is spinning on its axis. So every day, I've got a little Earth here. I don't know if you can see it, but every day the Earth spins on its axis, and that's what makes a day, right? And then the moon spins on its axis as it goes round the moon. And the reason that we only see one side of the moon is because its rotation, the way it goes, here we go, I've got two Earths. We're gonna have to imagine one's the Earth and one's the moon. But as the moon goes round the Earth, the same side is always facing it. And if you try that, you try it with something, perhaps with a circle or a roll of sellotape, and you work it out as you go around, you'll see that the moon makes one rotation on its axis the whole time it goes around the Earth. That's why we always see the front side of the moon. So if the moon for some reason stopped spinning, it would still be going around the Earth, but we wouldn't see the same side of the moon. So we'd actually see the moon change as it went round, because it would stay in the same place spinning, but it would keep going around the Earth. And then you imagine we'd see all the different sides of it as it went round and round. So the moon would look different to us. If it was still orbiting the Earth, we'd still see tides. So the moon affects the tides. So I think it's a very good question, and I'm thinking out loud, but I think the main thing we would see is that the moon would look different to us, but it would still stay in space. So there you go.
Thank you. I think we probably need to be thinking of our last few questions, and a number of them seem to be about elves.
What about the elves?
Quite a number of different schools have asked about elves. St Margaret's Primary School want to know how the elf got there, and another school wanted to know whether the elves in the space station caused any mischief.
I don't know how they got there. I think that's all the elf magic, isn't it? If I knew, I wouldn't be able to tell you any, but I really have no idea how they got there. It's the elf magic. Have they caused mischief? Yes. Absolutely, they get up to mischief in the space station. I mean, you saw the way they were looking at that freezer. I don't know what happened next, but I have seen evidence of the elves getting into the food and nibbling on it. They look at the experiments and they do wonder if they can switch things off. And sometimes, and it's always around about Christmas. You remember I told you about the space station and how I had a big problem at Christmas? The space station always seems to know when it's Christmas. Something always seems to go wrong round about Christmas, and I wonder if it's the elves and the elves pressing things they shouldn't. So you watch out. Things go wrong on the space station at Christmas. I promise you, they really do. And I reckon it might just be the elves.
Two questions that are related. One school wanted to know how long it took for the astronaut to learn what to do with all those buttons. An Alderton Junior School Peake class, Bella has asked, do the astronauts need to be careful that they don't press the wrong button?
Oh, that's two brilliant questions. So they do. It takes them years and years to get ready to go into space. When someone is selected and hired as an astronaut, they have to do 2 years basic training just to learn how to be an astronaut. And then they're eligible to be assigned to a mission. And they have to normally do another 2 years or so after that. So 4 years of training just to go into space. And all of that is learning what all the different buttons do, what the science experiments do, what happens if something goes wrong, if there's a fire, what do they do, how do they get back to space. They've got to learn Russian, they've got to learn English if they're Russian, lots of things to learn. So they take years and years to learn all those different buttons. And they do have to be really careful not to press the wrong button. Now, we try any button that's going to do something really bad, if you press it at the wrong time. We try and have a cover on it to make sure that it can't accidentally be pressed, but sometimes they do happen. And I remember once when I was in mission control, we had a really important live discussion going on between the astronauts in space, and it was I can't remember who, but it was a prime minister or a president. It was somebody really important, I think from Germany. And halfway through this live link, the astronauts accidentally elbowed the button that was the fire alarm, and the fire alarm started ringing out through the space station, and the astronauts knew what they had done. So they sort of just kept talking, but everybody in mission control was getting really worried because the fire alarm was going off and they didn't know why, and the astronauts weren't interrupting this really important conversation with the president or whoever it was to say, oh yes, we'd accidentally just elbowed the fire alarm. So they put a cover over it after that to make sure it couldn't accidentally happen. So sometimes it does happen.
And our last question, which is a question that's been asked by many children, is have you ever been to space and would you like to go?
Oh, what a lovely question. I have never been to space. I'm not an astronaut. And I would love to go. If anyone can give me a ticket, I would be great. I'd love to go. But I have floated. So I have been weightless like the astronauts. I've been really lucky, and I got to fly on an aeroplane, very special aeroplane. The same as sort of the ones that you might have been on if you're going on a holiday, but it's flown by 4 pilots and it's specially prepared. And this plane flies along in what we call parabolas, so big arcs. Essentially, it's flying along like this, and then their pilots put the engines on really, really strongly, and it basically gives the plane a kick, a bit like if you were kicking a ball. And if you kick a ball and it flies up and down and through the air, well, that's what the plane does. And while it's going through the air and it's going up and down and over the top, they managed to control the plane so that everything in it is weightless, is floating like the astronauts. And I got to do that, and it was brilliant fun. It was lovely. I should show one day. I should get a picture of that out. And it's great, and it really is so much fun. And I was there doing a science experiment, but it felt so natural and so lovely. And yeah, I'd love to go to space if I ever got the chance. But what I will say to all of you out there, if any of you are thinking you'd like to go to space one day, I think you could. I really, really mean it. And I really mean this when I say you can in your lifetimes. We are now, it's a really exciting time. We're seeing something, hopefully this weekend, a company called Virgin Galactic are going to fly their spaceship too. And just like that aeroplane I said goes up and over in a parabola, they're going to fly rockets, not all the way up to the space station, but into space in a big arc, in a big parabola. And people who fly in it can and experience weightlessness, floating for about 6, 7, 8 minutes and see the Earth, see those beautiful views. And at the minute it's quite expensive, but I really think in your lifetimes, if you start saving up, you might one day be able to save up enough money, a big chunk of money, but a bit of money where you go, I want to spend that on going into space because that's what I want to do. So as well as seeing humans going to Mars in your lifetime, if you want to, I think you'll be going into space. And I think that's really exciting. And there are so many jobs and opportunities out there that if space is something you'd like to do, go and do it. And if it's not, that's what I was saying, just go and do the things you'd like to do anyway.
Thank you so much for your time today. I know that there have been many questions, I think we've had over 1,400 questions asked. So we have never been able to answer all of those, but we'll put some of the questions together and get some of the space ambassadors to answer them. And thank you very much. And I'm hoping that you will get a very large number of people taking part in the competition.
That'll be wonderful. I hope so. I look forward to seeing all the entries and all the ideas. And I bet you're going to have some fabulous ideas out there. I look forward to it.
Thank you very much. Do you want to give them a wave before
Yeah,
I end the session?
thank you all. Have a Merry Christmas. I'm sorry I can't see you. Thank you for joining in today. It's been lovely to talk to all of you, and bye-bye.